as Bill said, and it's really important to stay at home to flatten the curve. I can give you some updates on what Levi's is doing during this kind of crisis. It's unprecedented for us, especially since we have shut down all our stores, and hence it also shows a good time for us to use data and AI to empower the company. So we've been working on analysis, which helps understand when we can open our stores, helps understand when the virus would have lost its virality, forecast all of those trends, and then present that to the executive team so that we can develop a plan on when we can open our stores, how to bring all our workers back to the full extent, and then working on problems such as understanding how much labor hours are needed per store so that we can keep all our store employees employed, and then how to bring more traffic to the store. So we've been working on a whole lot of diverse problems during this period of time to help our company to overcome these challenging situations. And without further ado, I can go into my presentation today, which is on personalized recommendations. So I'll be talking about all the flavors with respect to recommendations and also how to scale them. So before going into that, I just want to introduce how we use recommendations. I'm sure most of you are aware of these, but just a refresher. So we use recommendations for everything, literally, like movies. Of course, Netflix is one of the prime examples of having their entire homepage filled with recommendations.
Hey, Divya, sorry to interrupt. Maybe you want to slow a little bit slower, because this is probably easier for a remote user to hear and to adapt. I think you can, if you can speak,
okay.
Speak a little bit slower, it's better.
Okay, sure.
Okay,
so
thanks.
Yeah, sure. So Netflix is basically having their entire homepage as recommendations. So over 80% of what people watch in Netflix comes completely from recommendations. And Netflix obviously are having their recommendations driven completely by machine learning. Then other examples include music. So Spotify is one of the premium services for music, and they have multiple ways of recommending music. So they have their Discover Weekly, they have specific mixes for each and every user, and so on. So all of those are based on recommendations and many recommended algorithms. And other example, which is more close to home for us, is shopping. So Amazon, this is a screenshot from Amazon. So Amazon is one of the pioneers for recommendation systems, both from using them on their website and also developing a lot of algorithms that's being used right now. So they have multiple flavors of recommendations on their website, each of them based on multiple algorithms, which help the users find what they really need. And for today's agenda, I have divided the presentation into 3 parts. The first part is the business needs. So before building a machine learning solution, it's really important to understand what will it serve for the business? How is it going to be important for the business? So understand from their perspective, how can we make it better? Then the next item is more on machine learning. So understanding the different algorithms that are being used in recommender system at Levi's, and what are our different plans for improving them and how can we make them better. And then the third part of the presentation will be focused on engineering, which will help to understand how we have scaled our system so that we have millions of customers who reach our website, especially during Thanksgiving and Christmas. So it's really important to build a scalable system from a data engineering and data science point of view so that it can serve all those consumers on a real-time basis. So let's start with business needs. See, there's a question. Let me see if I can. Okay. Yeah. If you have any questions, please type them as we go. I'll be happy to answer them as we go, or we could do it in the last 10 minutes as well. So before going into business needs, I wanted to show an example of how recommendations exist offline. So we also examples of how it existed online. And this specific example is from Levi's. It's from a review for a person who shopped at our store. So if you can see the review, it clearly says that Tanner was super friendly and helpful from the moment we walked in the door. He was very knowledgeable about the different styles and helped me find exactly what I was looking for, even though I wasn't expecting to find it. He made the experience so much better, and I found some amazing pieces. So I have outlined certain parts in yellow, which are very important. So the experience was super friendly and helpful. It was extremely knowledgeable, and it helped them find exactly what they were looking for, but also what they weren't expecting to find. So this gives an idea of how we can define the qualities of a good recommender system. Of course, these are the qualities that we defined before we built our recommender system. We wanted to make the customer journey more intuitive and completely frictionless. We want to best reflect and communicate our organization's brand values. So this is very important to us because Levi's is a 165-year-old brand selling jeans from the gold rush era. So it's really important that if we are showing something as a recommendation to the user, it has to align with our brand values. And we have to focus on what consumers want and not who they are. So an interesting example here is how Facebook and Google went from just demographic-based ad recommendations to using browsing-based ad recommendations. So it was a huge shift back like 5-6 years ago, where they moved the shift. This happened because when you just show ads which are based on demographics, you miss the browsing patterns. So if a user's demographics is say male, but let's say they are trying to shop for a female, and if we keep showing them ads or recommended products with respect to their known demographic, which is male, then we are not capturing the fact that they're buying for someone else, right? So what we want our recommender systems to focus on what they want and not on who they are. And we also want our recommender system to use both implicit behavioral markers and explicit input. So what is implicit behavioral markers is things like they just browsed a product, they have added to cart, they have clicked on products, and those are what we call implicit markers. Explicit inputs are typically what is like ratings or things they have bought and things like that, because they're explicitly telling us that they like that product by giving a rating, a high rating, and then they explicitly tell us they like the product by buying them and not returning them. So we consider those as explicit inputs and implicit as everything else. So in Levi's, we are very rich in implicit data when compared to explicit data, because we do not require all of our users to log in when they have to buy, because we allow guest checkouts. So unlike Amazon, we don't have a lot of explicit inputs, and we don't have a lot of users even giving ratings to our products. So we rely a lot on implicit behavioral markers for that reason. And the last point is it provides relevant information in a timely manner to expedite decision making. So basically, it depends on the placements of recommender system on different pages so that it's in a timely manner and it really expedites them to make the purchase. And the next part is consumer touch points. So we have multiple touch points for each and every consumer. So they move through multiple phases before they make a purchase with us. So let's take one phase, it's awareness. So awareness starts from going through a campaign, seeing from word of mouth from other people, seeing other people wearing our jeans, digital and so on. And then slowly the consumer moves into the phase of consideration, which involves coming to our homepage, reading blogs, and so on. And then they slowly move to purchase, so they can purchase through multiple channels. They can call a call center. They can go through our website. They can buy in our stores. They can also buy in our wholesale partners like Macy's and so on. So then we move to service, post their purchase, where they can contact us in multiple ways, and post that they move into our loyalty, where we try to keep them engaged by giving them more promotions, by sending them emails and so on. So trust me, we have built recommendations for all these platforms, whether it goes from ads to homepage to service centers to loyalty. We have recommendations at every point. So it really proves how important recommendations are in order to make the user make that purchase. So throughout this presentation, I'll be talking only about the landing page experience, because that was our first experience that we built and scaled. But just remember that we have recommendations on all the other touch points as well, and all the other pages on the website. So before going forward, I wanted to show you what was the experience before we built our own in-house recommendations. So we had Adobe's out-of-the-box stagnant bestsellers recommendation. It was the same for every single user who came to our website. So this is kind of the experience. So you can see there are multiple problems with it. The first problem is it has a generic title, which says recommended for you. Even though this is not recommended to a specific person, it's a non-personalized recommendation because it's the same for every user. So that title is kind of misleading. And we have a lot of mixed gender products. So there's one male jeans, and then suddenly there's a female trucker without any understanding of why that's being popped up. We have a mix of sale and non-sale items. And also we faced another problem of the product refresh from Adobe happens once in 24 hours. Sometimes we would launch a sale midday, so the price would not even be reflected there. And hence it would be showing the wrong price for the whole day. Whereas when the user clicks on the product and goes inside, they would see a different price. And that was a really bad experience for the user. So we also have research from Bazaar Voice, which says 38% of the consumers say they won't return to an online retailer that recommends things that don't make sense for them, like these bunch of products, which does not make sense for the user, because let's say the user is a female, then they just see a couple of products for them, and most of them is male. So we need to understand who the user is before making these recommendations. So the goal was very simple: to help our customers in their product discovery journey by recommending relevant products. The motivation to go in-house is basically the data. So we collect a lot of data, and we can make better decisions on what to show the user without it being freakily relatable. By that I mean, all of us have experienced this thing that we talk about something and it immediately shows up on Facebook. We don't want that kind of an experience, but we still want to use data to help our users understand and make their experience better. And the second point is cost reduction. Of course, we don't want to pay to an external vendor when we can build this in-house. The third point is collaboration. So this is actually the most important point for our team, because we were a very new team when we started this project to the entire Levi's. So Levi's had not known of data science when we joined this team. So it is more imperative that we work across different organizations, different people, so that we understand the business better. So this project really provided us that avenue to collaborate with different teams. The fourth point is customized. So of course we can customize it however we want when we own it. So we cannot show any sale products. We can do a lot of customizations around it, which I'll talk through as well. And we also thought of this as building a fundamental capability, right? So once we built this recommender system, we were able to scale it and show it across so many touch points that I walked over. So we didn't have to rebuild it for every single use case. We can show it anywhere we want. We even went ahead and showed it for in-store stylists and so on. So it became really fundamental after a point. And then it also allows us to have continuous testing. So we can continuously test the code cycle of a third-party vendor. So before we went ahead and did the thing, we involved with so many teams. So some of the teams are listed here. So business teams to basically understand what they wanted to show. Market research, of course, to understand what's market research basically involves consumer insights. So we showed them multiple algorithms and see which algorithm really resonated with our consumers. A/B testing group to test it. Analytics, no brainer there. And merchandising to help understand what kind of products should we show. Is there some products that they want us to boost? Because we want some of our consumers to move from a certain fit to another fit, because that's what is more trendy. Like for example, we have 5'10" jeans with us, but right now we want all of the 5'10" consumers to move towards the 5'11" fit, because that's more comfortable and it's more tapered and it's in trend with the fashion. So we can boost those products. Then we have site personalization. So basically, these kind of personalized experiences fall under the realm of site personalization. So we worked with their team. Then we worked with data engineering, of course, to develop the pipelines. We worked with DevOps to develop all the Jenkins jobs and so on. We developed UI, UX for how it's being shown and so on. So multiple teams involved in one effort. And some examples of what came out of scoping. We definitely want in-session personalizations. We don't want to show what Adobe did. So we want to update our recommendations. If the user is browsing, the recommendation should be updated. Then we also did not want any highly discounted products for new visitors. So new visitors, meaning we don't have their cookie ID, they haven't purchased with us, they haven't browsed with us. So why show them highly discounted products was our understanding. So we removed them. Then we don't want to show some special experience product where the users need to provide ID. So some examples of these are, we just launched our Super Mario collection. So some of those items are not available to everyone. It's probably available to certain of our users who are, say, are highly loyal customers, or this is a special experience product or something like that. In that case, we will ask the users to provide their email ID so that they can go and experience that product. So it gives a sense of novelty of our product releases. So we don't want those products to be shown on homepage for everyone, right? And then the next one is inventory checks. So that was a huge problem with Adobe as well. So we would show products which are not in inventory, which do not have stock for most of the sizes. So that means the user clicks on it and do not find their size and is frustrated in the journey. So we developed a separate algorithm to help us understand inventory scores, which are based on what are the most commonly purchased inventory and also based on demand forecasting. So it's a very robust score which tells us how size broken a product is. And if it's very size broken, we don't recommend it. And we wanted dynamic UI titles, which warranted continuous testing. So we don't want a generic title which says recommended for you. We wanted every experience to have a different title, and we wanted to experiment more with it to see if it has any positive impact if we change the title and the messaging. So those covers all the business needs. So I want to move to the next section, which is machine learning. So what are the algorithms that we used, and what are the flavors that we experienced? Before that, let's talk data. So what are the data sources that we need to build these kind of personalized systems? So whenever a cookie comes into our website, we do record their location, we record their device, we record their channel, and after that, we also record their actions that they perform on the website. Like they're browsing certain things, they are navigating to certain pages. So those all are implicit indicators of what their preferences are, and we can make sense from that. And then we also record all their browsing actions, what products they browsed, what products they added to cart, and so on. We also have details about their purchases if they have purchased something which we can attach to the cookie ID as well. So these are some of the data sources that we use. Of course, it's not an exhaustive list, but it's an sample of what are the data sources we can use for these kind of algorithms. So let's go into the algorithms itself. So the first algorithm I'm going to talk about is popularity-based recommendation model. This is for people who we have no clue about. Like they have never purchased with us. We have just got some basic information about them, like their location, channel, and where they're coming from, device, and so on. But we do not know anything about them. They have never browsed with us, or we haven't recorded, or they have cleared their cookie cache or something like that. We don't know anything about them. In that case, we use what is called popularity filtering model. So we have developed about 15 different metrics. The metrics are things like conversion, average unit retail, inventory scores, and so on, and diversity of products, and so on. And then we choose 10 products that will show to this group of consumers. Again, the diversity score is important here. So we'll show a mix of men and women's products because we still do not know what is the gender of this person. So it's important to show a mix of products. And also we will use things like conversion and other metrics in order to make it useful for the business as well. So we used a combination of all those metrics, and we looked at the data of all the users who have purchased with us to make that recommendations of what products to recommend to the final users who come into our website. We'll talk about it when I show the particular experience as well. And the next type of algorithm is collaborative filtering. So collaborative filtering is one of the commonly used algorithms. There are many flavors in collaborative filtering, but in general, what it does is, I will go into detail in the next slides as well, but in general, we basically take a consumer's transactions and try to find either a similar consumer to them or a similar item to what this user has purchased, and then recommend some products to this user. It started out really well on movie recommendations, and then it has now moved mainstream to shopping as well. And when I go into the flavors, I'll give more clues on how the algorithm actually works. So collaborative filtering can be done in two ways. It can be done as a model-based approach or a memory-based approach. So a memory-based approach is basically it's called memory-based because you store all the user item transactions in memory. So basically, you can imagine it to be a giant matrix where your x-axis or your rows are basically the users, and your columns are basically the items that they purchased or interacted with. And we can find similar users based on making all of those interactions into vectors. So for each user, there's a vector representation of the items that they viewed, or for each item, there's a vector representation of the users. You can do it either way. So if you do it at a user level, it's called user-based collaborative filtering. If you do it at an item level, it's called item-based collaborative filtering. And you can then find similar users based on cosine similarity of these vectors. Or you can do and take an average, weighted average of ratings. We don't do ratings, we take a weighted average of their preference. So if they added something, if they purchased something, then you give it a score of 5. If they added to cart, then we give it a score of 4. So we do it that way. And then the advantage of doing a memory-based approach is it's easy to create it. It's extremely explainable. So when our stakeholder comes and asks us, hey, why did you recommend these products to me? It's super explainable. So those are the advantages of using a memory-based approach. The disadvantage is the performance reduces when the data is sparse and it's really not scalable. We had about 8 million consumers that we score every day, and we are still able to scale it using memory-based approach, but I do know that that's not sustainable. So we do both model-based and memory-based, and we can switch between them. So model-based is basically, it uses machine learning, so it makes it a supervised problem to predict the user ratings of unrated items or unbought items. And then we use algorithms like PCA, singular value decomposition, matrix factorization, deep learning using neural nets, and many ranking algorithms as well. So the advantage of this is, of course, there is easier. Dimensionality reduction is easier. It's very good and deals with missing and sparse data. The disadvantage, of course, is inference is untraceable because it has a lot of hidden and latent factors, especially when we go the deep learning route. Each layer uses a certain set of factors that it has detected, and that's not very easy to communicate because it kind of becomes a black box at that point. So that's the disadvantage of it. So how we approached it is we started with memory-based approach. And once our business holders and our consumers have faith in us, then we switched to a model-based approach. So people know our recommendations are good and hence understand it really well. So then we could tweak it to model-based approach. But even the model-based approach are pushed through consumer insights, checked if they are interpretable, if the consumers understand what they are recommended for before going for which model to choose among them. And this is another idea of user-based and item-based. So basically, you can see that this person liked grapes, strawberry, watermelon, and orange. And then the next person liked strawberries. And then the third person comes and they like strawberry and watermelon. So now we find similar user who liked these two products. So we find that this user also liked strawberry and watermelon. So we find what are the two products that we can recommend are the products that has not been seen by this person. So we can recommend grapes and orange. So very simplified example of how user-based collaborative filtering would work. Whereas item-based collaborative filtering is the opposite of it. So we see from the item side, so we see who really, what is being co-bought with each other. So we can see that grapes is being co-bought with watermelon and orange. And in the second transaction, grapes has been co-bought with watermelon. So we can see two transactions have grapes and watermelon to be co-bought with each other. So maybe they are similar items. So this is the premise, a very simplified form of the premise of how the vector representation varies between these users. Then there's content-based filtering model, where it's dependent on purchase behavior. We use text embeddings and image embeddings. So what our content-based filtering model means is, this is what we call as similar products algorithms. So if a user is browsing something and we want to recommend similar products, we use a combination of all three behavior to recommend them to them. And why we use content-based, why not just use collaborative filtering, is because we have things called cold start problem, right? So collaborative filtering will work if a certain product has been purchased. But what if we launch a new product? Like yesterday we launched Super Mario Collection, and that has not been bought by anyone. So collaborative filtering will never recommend a Super Mario product because that has never been bought, never been seen, never been browsed. So how do we recommend it to the new user? So in that case, we go the content-based filtering model route. So we use the purchase behavior, yes, but we also use text embeddings. So we try to do like TF-IDF and word-to-vec and many natural language processing models to find what are similar products to each other. I'll go through them in detail. And similarly, you can use images to find embeddings. So text embeddings. So when you look at this model wearing this pair of jeans, you can see that it has so many attributes that are being recorded in the backend. This is just a sample of them. We have more than 500 attributes for a particular pair of jeans. Like we know the gender, we know the name of the product, we know the product type, the material, the wash, rise, what is the size group, fly, and so on and so forth. So we can combine all of these attributes and find a embedding space for it. So for example, this is just showing a 2-dimensional version of it, but imagine you can do it over 100 dimensions or 500 dimensions as we did. So if a product is high rise and say 100% cotton, and they're all clustered together. And if they're high rise and 70% cotton, they're clustered together, low rise here and 100% cotton here. So we can use this as a neighborhood space. So let's say our product that is being newly launched is somewhere here, which is like which is a red spot, which is high rise and 100% cotton, somewhere at like 80% cotton. We can find the neighborhood space of it, and then use these products as a recommendation for them. So this is a very simplified case, but imagine we can do it in a 500 dimensional space as well to find what is in the neighborhood and recommend those products. So we use what is known as document similarity. So we take the source text, which is the descriptions of all the products, and then you could just use a simple TF-IDF, or you could also do word-to-vec and convert that into a vector representation of all those words, and then find what is closer to each other by using like cosine similarity or other similarity scores in the 500 dimensional space, and then recommend those products to the user. Then we can move on to image embeddings. Image embeddings is super interesting because, as you can see, this is an example of a panda. So we can take the ImageNet database. We use different data sets, of course, which are like deep fashion and other things which is related to clothing industry. But what we do is we use this technique called transfer learning. So we take that whole data set and train a more complicated model and let it mix. It can just predict like jeans, tops, and so on. It won't really predict Levi's specific labels, but that's fine. But we can use this model, which is trained on a corpus of say 200 and 300,000 images, and then put our 8,000 images, that's kind of how many products we have, through a network, which is very similar to this network because this network has been trained and works really well, super accurate, and so on. And then use those weights without having to retrain again, and use the learnings from that huge corpus, and just remove the last layer. So the last layer in this case was predicting between panda and raccoon, and we can make the last layer to predict a dog, breeds of dogs. In this case, we just removed the layer, added a new layer, and made it predict between Chihuahua and say a Pomeranian. And then the classifier correctly predicts this as Chihuahua, because this network's learning needs to be done on a huge corpus, or deep learning does not do really well. So we can make the deep learning project to work on a completely different context, which does not involve our data, and then use the learning, basically the weights and how the parameters are defined for the network, and use that on our data to predict that. So this really gave us a huge edge of predicting what product is similar to each other. We also use this for other purposes like attributing our products. So we don't have good attributes when we have damage on our jeans, and hence we use these kind of models to auto attribute our products. So really a lot of work on image embeddings from our team to make that a reality. So again, the same things represented here. So we take a large input data set with 100+ categories. ResNet is an example. We use multiple other networks as well. And then we use a softmax layer, and let's say it says giant, panda, red panda, raccoon. Then we take a smaller custom data set with only 10+ categories, which basically can be like red jeans, blue jeans, or jeans with damage, and so on. Those are our classes. And then we use the frozen weights from the before network, and then just change the last few layers to represent what we wanted to show, which is jeans, tops, and shorts. And then also do some, add some dropout layers and some dense layers, and make use of backprop to help classify jeans, tops, and shorts. And then we remove this layer and only take the embeddings that are there in the penultimate layer, and then use those embeddings to find what is similar to each other. So this is an example of how it would come out. So each jeans can be represented by an embedding, which could be how many ever dimensions we want. We use currently a 2,400 dimensional vector to represent a single jeans. And then we just find what is the similarity between them. So let's take this genes had this 2,400 dimensional vector. Then we find which of those vectors are similar to each other. In this case, we found this genes to be most similar. So it had a 0.6 score. So we would just rank it based on the similarity scores. So now that we have covered all the algorithms that we are using, we can move to how do we actually personalize. So we do it across 4 buckets: awareness, consideration, intent, and purchase. So awareness is first-time shoppers. Consideration is they've just had browsing behavior. Intent is people who have added to cart, and purchase is people who have purchased. And then for the awareness group, we recommend the popularity-based recommendation that I talked about. And then we do ranking based on location, device, and seasonal purchase patterns. So someone from California sees a different recommendation than someone from Arizona using their desktop. And this is kind of the experience. So you can see the title is very clear. It says recommended bestsellers. It has some men's products, it has women's products, it has a combination of both. There is no hard mark products here. These products are completely in stock and so on. Then consideration. So this is people who have some kind of browsing behavior but have not added to cart or purchased. In this case, we use similar products recommendation that we spoke about using product attributes, product interaction, image embeddings, and all of those things that I spoke about. And it's being ranked based on the last product they interacted with. So add to cart products will have more similar products shown first, and click will have after that, view will have after that. Then this is kind of the experience. So this is someone who's been searching girls collection, girls t-shirt collection. So you can see that it picked up on that and it showed them some girls t-shirts. And here we can show sale products because it seems like the user is interested in some sale products. And intent is visitors who have added to cart. So we use collaborative filtering here. And again, it's weighted on intent and actions. And then we change the title again. We call it because you shop similar styles, and show them a bunch of products. So seems like this user is interested in both tops and jeans. So we show a mix of them. And purchase is similar. We have people who have purchased with us, but we do something different here. We, what if they have purchased and they've browsed after that? So we want to use all the interactions after they've purchased. So we rank the browsing interactions by using an exponential time decay, and then find the top 10 products that will be liked by the user, and then put collaborative filtering on top of that. And then we rank it based on intent and actions again. So we then call it because you bought similar styles. So this person seems to like both men's and women's product, or is predominantly a man, but also buys some women's products for, say, for his girlfriend. So we show a mix of both. So in the interest of time, I will go into the engineering a little bit faster. So we had many versions of engineering that we did. So we tried Elasticsearch and did not work out. So we went into a much complicated one where we take all our clickstream data and put it into Redis. And we have an API gateway that listens to the DynamoDB and so on. Then this is the final architecture that worked for us. So we have the ALB fronted, which is application load balancer fronted EC2 instances, where we have Python application hosted, which is our API. So the API is what hosts the decision logic. So it decides whether someone's a new user and what recommendations to pick from. And all the recommendations are being run by batch jobs and stored into Redis cluster. And then we also have some feed that is coming through a webhook and being stored into Redis. So we have actual browsing interactions that's happening right now being stored here, and batch process, which shows purchases as of yesterday, and that's also being stored here. And recommendations based on them is also being stored. So Redis is our main database, and we use the API to have the logic to say which recommendation should be shown. So in general, to give an idea, for each user, we have about 50 different algorithms that's being populated. And in the end, we choose one of them and show it to them. So this is kind of like a new architecture that we have worked on. So we changed all the batch jobs from running on EC2 into AWS batch. Then we have a scheduler using step functions. Then we made it a Kinesis stream to filter out events that we want. Then we use ECR, and we use ECS ranking algorithm. So it makes it more flexible, and that's like our new architecture that we are launching as of this month. So all these interesting things. So what are the results from A/B tests? So we did an A/B test between Adobe and our experience, and we found that our experience had a conversion rate of 4.5% higher than what Adobe had, and that led to 4.4% increase in revenue per visit, and it led to a revenue of more than $2 million just on our homepage. So it was really a big deal to launch this kind of an experience on our homepage, and hence we then scaled it to other pages and stuff like that as well. So thinking ahead, we had many tests and many successes. So we have it on cart, we have it on product detail pages. Any page that you go on Levi's is being powered by what we have built. Then we are launching them on email campaigns. So email campaigns are getting personalized recommendations from us, stylist apps. So when you go to a store and you go to a stylist and ask them that, hey, I like these jeans, can you show me something like this? Then they open up their app and our recommendation is on them. Then we use them for customer service. So when you call a customer service agent and be like, I really like these jeans, but it's out of stock. Can you tell me something similar to it? They're able to recommend. So really empowering a lot of human decisions as well from our end. And then we have used it in many weird areas that we did not think of, like trend forecast. Like trend forecasts typically suffer a lot when you introduce a new product because of cold start, because it does not have a history. How do you forecast for it? So our model is giving you embeddings, which will tell you what product is similar to that. So we can use that in a proper regression model as a feature and be able to give more accurate forecasts. So really a lot of advantage in that kind of usage. Then we are scaling it across brands. So we have 4 brands at Levi's. We have Levi's, Dockers, Denizen, and Signature. So we have scaled it across all brands. We are scaling it across geographies, so moving it to Europe, moving it to Asia, and platforms such as mobile has a different version, desktop has a different version, and apps have a different version, and so on. And algorithmically, we are planning. This is something that we are planning. So we plan to use user-generated images for style recommendations. So users come to Instagram and always put their images when they wear Levi's. So we are asking them for permissions to use them as part of our algorithms and use them for style recommendations when users come to our site. And we are trying to use Bayesian personalized ranking and other ranking algorithms as well to help rank the products better before serving them. And we are also trying to use purchase propensity based recommendations. We have separate models which help predict what is the propensity of someone purchasing a certain category, and can we use that to provide better recommendations, and of course lifetime value based recommendations. So all of these exist as separate models, and we are trying to integrate them into this whole recommendation ecosystem. So that covers my presentation, and I want to give some time so that you guys can ask me any questions you have. Thank you.
Great, thanks. So for folks, if you have questions, you can either type in the chat window or you can ask in the Q&A sessions. So when you type questions, make sure to address to all panels and panelists and attendees. Okay, seems like the talk is clear as a mud. So everybody is no questions, very clear.
Okay, thank you. And if you have any questions, oh, I see one more question.
I think the one is coming.
Oh, yeah. Is Levi's planning to outsource your group skills to other related retailers? We do some work for other related retailers. Like, for example, we do build models that help us for our wholesale retailers. So we have some partnerships with certain of our retailers where we use our data and their data as well, and then give them suggestions on how they can do certain things. So one specific example can be inventory optimization, right? So let's say Macy's and Kohl's come to us and they always place orders with us. and let's say some of their units are not selling as much, we have ability to help them out. So what we do is we participate in the inventory forecasting and tell them, hey, this is the recommended amount that we think you can sell based on your past transactions. So this is our suggestion for how much you can order from us. So that really helps them to save on their inventory costs and also helps us. So that's kind of how we outsource our group skills to other retailers. Then we also have data partnership with other retailers where we share our data with them and they share their data with us, and we help them make some analytics out of them. So we do those kind of one-off partnerships, but these are some examples that we do it. And the next one is, can we get the PowerPoint presentation? Yeah, sure, I can send it to Bill, and then, or you can just contact me over LinkedIn and I can share it with you however it works out. And do you have any learning to rank model? If yes, what also is used? We do have a learning to rank model. So that is our Bayesian personalized ranking model. It did not do that well. So we're still researching on it, because when we passed it to consumer insights, they did not find that experience as good as our collaborative filtering or matrix factorization that we have. So we are trying to of doing that. So that's kind of where we are at. But in general, what we are using is collaborative filtering, but multiple flavors of it. So we have things which are model-based and memory-based, as I explained. So we have both of them, and we have multiple models underneath them. So that's what we are currently in production with. How easy did it make to switch your DevOps from Amazon to GCP? So we are still on Amazon. We are planning to go to GCP. I don't know how you are aware of that, but it's not easy. It's going to be a tough process. So we are working through it, is what I would say. And it's not going to be easy, is my understanding. And how did you measure your success? Example against Adobe. How we measured our success is we ran an A/B test. So our control is Adobe, and we used conversion as our primary metric for all our tests like this. So number of people who ordered divided by the number of visits. A number of visits which saw the recommendations others, and we use the second metrics and revenue per visit. In general, we found our algorithm to have a lift in all metrics, hands down. So that was kind of very surprising for us as well. We were planning to change our optimizers based on which one did not perform well, but it really optimized just on both. How to compare similar different models on price points, so have their added price. I am not sure if I understand this question correctly. So how we compare models, meaning machine learning models, we compare the machine learning average precision at K. That's kind of a metric to compare. And with respect to price points, if that's related to how we have price points on our products, I'm not sure how we can answer that. And next one is improvement in structure, recommending, we were putting all our batch jobs in the EC2 instance where it runs on cron tab. Really not a good solution, but we didn't have data engineers at that point. It was just me cranking it out. So I just built it that way. But now that we have data engineers, we made them put all of that in batch jobs. So that makes it, AWS has something called AWS batch, which makes it more structured and easier to debug and stuff like that. And also added a bunch of logging. So really a lot of logging, Slack logging and notifications and all of that. If something breaks now, we are hyper aware of it. We also added that ECS instance, so that helps us to scale a little bit better. And also the API gateway now has a decision-making logic that can be changed a little bit. So a lot of those kind of tiny improvements that really could help us to get better performance is kind of where it is. And next question. what recommendations would you give to others building similar systems for their brand? So my recommendation is start small, start really small, start with like market basket analysis or really simple algorithms to first help your users or your business people trust you. So that really was our biggest challenge. So when we did all our fancy algorithms and showed them the recommendations, we would keep on asking, how is it you're recommending this product to this user? Can you show me all the things that they have done? So building that trust was important. So first we started very basic. We did collaborative filtering item to item. Similar products I was just based on text embeddings. We didn't do anything fancy. But once we got their buy-in, it was really simple for us to scale into advanced algorithms and prove our chops. But that really would be my biggest advice. And also another advice is to focus on engineering first and get that pipeline and scalability aspect ready. And then you can always go and make your algorithms as good as you want. But remember to keep flexibility, that you can be super agile in changing the algorithms and not have to depend on a cycle of engineering sprints and so on. So really think about all these things. And next question is, how are you getting rid of position bias in your models? Super interesting question. We are noticing a position bias in our models. When we give our models, first the products are what is getting clicked on, but we also see a bunch of users going to the 10th product and clicking on it. So the learning to rank problem is what will help us to get rid of that. So that's kind of why we are working on learning to rank problems, so that we can understand what is it, why are some people going to the 10th product and clicking on them. It's because our ranking wasn't that great. So really working on that part of it. And what is the biggest challenge among the 3 themes in your outline: business, ML, engineering? Can you provide one specific example? Yes. So the biggest challenge among all of them is business, because it's really tough to convince business that let's go in-house, let's go and do something like this. This is going to make you more money than just using an Adobe out-of-the-box solution, because there's a lot of investment, right? Like when you saw, it's not only data science. You have to get so much time commitment from so many teams, engineering sprints to launch them. Then there's just so many things that is involved. So getting business buy-in was the biggest challenge for us. Right now, that is the easiest part, because once you get the buy-in, it is always uphill in their end. Whereas right now our challenge is more on engineering. So we built the solution that's okay, scalable, but right now we are working on making certain, like as I said, we ran into a lot of issues when you just run in on an EC2 instance, which is just associated with one single user. No one can go and modify it. So if I go on leave, then if something breaks, there's no one to modify. So working on engineering to make it better and scalable is kind of our challenge right now, but I think we are in a good place there. ML has never been a challenge for our team, because we were all data scientists to begin with, whereas to understand business and engineering concepts is what took us some time. And which model has better outcome, user or item-based filtering, popularity, collaborative, content-based filtering? Item-based filtering has better outcome based on how our users are. When we use user-based filtering, what's happening is most of our users buy only jeans, and hence the other items never come up. So it just everyone gets recommended men's jeans. So really was a bummer. So item-based filtering really works for us, and even Amazon currently uses item-based filtering, and it's kind of what they discovered as well. So kind of works better. But we do have a flavor of user-based somewhere in some pages. So it really depends. We run a lot of tests on them and see which one works really well, but item-based on most pages. Popularity, collaborative, content, a mix of all of them. We have all of them in every single algorithms, because collaborative faces what we call a school start problem. Popularity faces what we call as what products are being frequently purchased, whereas content-based filtering is able to overcome those two things and show the low purchase items as well. So we use a combination of all of them. We call it hybrid recommenders. So we use all 3 of them at any point in time to recommend a certain product. So mix of all of them would really work well. So these are really interesting questions. Thank you so much. And do you guys have any other questions? Another thing that I wanted to highlight is we are hiring, even in this scenario, we are hiring. Our data science team is still hiring. We have multiple analyst positions open, data scientist and machine learning engineering lead and machine learning engineering roles open. So if you guys are interested, please feel free to reach out to me on LinkedIn, and I'd be happy to refer you.